Gasoline fuels the engine, but without electrical systems, a car or truck wouldn't run. In fact, you couldn't even start it. Ignition, interior and exterior lighting, power locks and windows, heaters, fans, safety restraint systems, all of these are powered by electricity. In this program, we're going to take a look at a vehicle's electrical systems. You'll learn some basic terminology and concepts that you'll need to test a vehicle's electrical circuits and components. You'll learn some important safety precautions to take when working on a vehicle's electrical systems. You'll see how to use a digital multimeter, or DVOM, the most important tool for electrical testing. You'll learn how to perform a battery state of charge test, and how to inspect and clean a battery and its cables, connectors, and clamps. You'll also learn about fuses and circuit breakers and how to test and replace them. Finally, you'll see how to inspect an alternator and fix some common problems. Let's begin with some concepts and electrical terminology that you'll need to know if you're going to work with a vehicle's electrical systems. All electrical circuits have a power source, conductors, and a load, a device that converts electrical energy into light, heat, or movement. The power source in a vehicle's electrical system is usually the battery. The battery has positive and negative terminals. Electrical current flows out of the positive terminal and returns to the negative terminal to create a circuit. If there is a break or open in the circuit, the electricity can't flow. It does not have continuity. If the circuit is complete, it has continuity. This flow of electricity through a circuit is called current. Current can be compared to the flow of water through a garden hose. It's measured in amperes or amps using an ammeter. The number of amps tells you how much current is flowing through the circuit. Using our garden hose example, measuring current flow in amperes is similar to measuring water flow through that hose in gallons per minute. Conductors carry the electrical current through the circuit. Conductors can be wires, or in the case of computers, extremely small metallic traces on a computer board. In our example, a conductor is the hose that carries the water. Voltage is the pressure that pushes electricity through a wire or circuit. It's measured with a voltmeter. Voltage is like water pressure. Resistance is a restriction that slows down current flow. It can be compared to a kink in our garden hose. A typical example of resistance in an electrical circuit might be corrosion on a wire or connector. Resistance in a circuit or component is measured in ohms using an ohm meter. Finally, the load is a device on the circuit that converts electrical power into another form of energy like light, heat, or movement. You'll measure current, voltage, resistance, and continuity when testing electrical circuits. Now, rather than having three separate tools, an ammeter, an ohm meter, and a voltmeter, you'll use this handy tool. It's called a digital multimeter, or DVOM, which stands for Digital Voltage Ohm Meter. This type of multimeter is recommended by vehicle manufacturers because it won't damage a vehicle's sensitive electronic parts. The parts of the meter we'll be using today include the zero key, which we'll use for calibrating the meter, the center dial that allows us to set the meter to operate as a voltmeter, an ammeter, or an ohm meter, and the lead ports. This meter is also auto-ranging, which means you don't have to set the value range for the circuits you're testing. Some older or less expensive DVOMs are not auto-ranging, which means you'll have to know the appropriate range of the device or the circuit you're testing. Before beginning work on a vehicle's electrical systems, it's important to review and follow safety procedures. First, always disconnect the negative battery terminal. This prevents an accidental electrical fire and getting a nasty shock when you're working on the vehicle's circuits. When disconnecting the battery, the ignition should be off to prevent a voltage spike from damaging any computer electronics. Don't smoke or weld near batteries or expose them to sparks, flames, or heat sources. Batteries emit hydrogen gas, which can produce an explosion if exposed to heat, flames, or sparks. Never tug on wires to remove connectors. That's a great way to cause an open, a break in the circuit that you'll have to fix later. Now let's perform some basic tests with the multimeter or DVOM. Before you walk up to a car and begin to test parts, you need to know about their electrical requirements like load and resistance. This information can be found in the electrical diagram section of the vehicle service manual. The service manual is also helpful in locating the routing of circuits you're testing. Most circuits and loads you test will get power from the battery and a return or ground from the vehicle's metal chassis. The negative terminal of the battery is then connected to the chassis and the engine block to complete the circuit. do a battery state of charge test. We want to determine if the battery has sufficient voltage to run the electrical systems in the vehicle. So we'll have to set our DVOM to measure volts. Since batteries produce direct current, or DC, we'll have to select DC voltage. The symbol for DC current is a solid line over 3 dashes. Voltage is represented by a V. With this meter, when you select your setting, the meter is automatically on. You'll also need to connect the positive or red lead to the voltage and ohms port and the black lead to common. With a non-auto-ranging DVOM, you'll have to select the proper voltage range. Most car batteries have a range of 12 to 14 volts, so you'll need to set your meter to that range. In this case, use a range of 20 volts. If your meter is auto-ranging, like this one, it'll automatically find the correct range when you begin the test. Now we're ready to do a resting state of charge test on our battery, meaning the car should not be running and none of the electrical accessories should be on. Touch the positive or red lead from the meter to the positive terminal on the battery, and the black lead to the negative terminal. A full charge is 12.6 volts or higher. The acceptable minimum range for a good battery is 12.4. Now that's when all vehicle electrical devices are turned off and the engine isn't running. Now if the battery tests lower than 12.4 volts, the first course of action is to recharge it, but we'll talk more about that later. Let's use our DVOM to do a test for resistance. When testing for ohms, there must be no power in the circuit or the ohm meter will be damaged. Either disconnect the part from the power source or disconnect the negative battery terminal. We're going to test the resistance of this fuel injector that's been removed from a vehicle. Resistance is measured in ohms, so turn the meter to the ohm setting. The symbol for ohms is the Greek letter omega. Before testing, you must calibrate the meter by shorting the 2 leads together and pressing the 0 key. If you don't calibrate the meter before testing, your measurements will be inaccurate. To test our fuel injector for resistance, put the 2 leads from the meter on the 2 terminals of the fuel injector. This fuel injector is not polarity sensitive, so we don't have to worry about positive and negative terminals. Compare the test reading with the resistance value the component is supposed to have to see if it's defective. If the component has an open or break in the circuit, the meter will show OL, or infinite resistance. This part is defective. A reading of 0 indicates there's no resistance in the component, and it's shorted, another defect. Every component has a specified minimum resistance value, which can be found in the service manual. If your test shows a value less than the specified minimum, then the component is defective and you should replace it. We're going to do a typical test for amperage on a fan motor using a car battery as our power source. Amperage is measured to test how much power is being used by a device or load. Set the multimeter to amps and direct current. Amps is represented with a capital A, and DC current is the solid line over 3 dashes. Also, move the red lead into the amps port. Now our multimeter is functioning as an ammeter. You'll also need to know the amperage specification of the component you're testing. This is the normal fan hookup. You must break the circuit and hook up the meter in series to measure the amps the fan is drawing. A low current draw means there is high resistance in the circuit, like from a bad connection or dirty motor brushes. A high current draw indicates a low resistance, like from a dragging or partially shorted motor. Now that you've got some basics on how to measure voltage, resistance, continuity, and amperage, let's take a look at fuses and circuit breakers. Often, when one of a vehicle's electrical devices doesn't work, the fix can be as easy as replacing a burned-out fuse or a defective circuit breaker. A blown fuse will typically have a break in the metal band or possibly show signs of heat damage. A bad fuse can also look perfectly normal. If you're uncertain whether it's good or not, test the fuse. Fuses can be checked by measuring for resistance with a multimeter. Switch to ohms and calibrate your meter. Then place the red lead to one fork of the fuse and the black lead to the other fork. This fuse is good. A bad or blown fuse like this one will show OL, infinite resistance. Replace it. All fuses have an amperage rating. Be sure you replace a blown fuse with one of the same rating. Circuit breakers, like fuses, protect circuits from excess current. Unlike fuses that burn through, circuit breakers heat up and open the circuit. Once cool, the circuit breaker will close and the circuit will be operational again. Circuit breakers are typically found in circuits that are prone to occasional overloads, such as power windows. If the window is jammed or sticking, the circuit breaker will open to prevent the motor from burning out. Like fuses, they're rated in amperes. Sometimes you may wish to check the continuity of a circuit breaker to see if it's faulty. Set the meter to ohms and calibrate it before testing. Touch the meter probes to both terminal forks on the circuit breaker. A 0 or low reading indicates continuity, which means the circuit breaker is good. An OL reading means that the breaker is faulty and should be replaced. The battery supplies the power. If it isn't working properly, the vehicle's electrical systems won't work. In addition to the state of charge test, you need to inspect the battery, battery cables, connectors, and clamps to make sure they're corrosion-free and in good working condition. But before doing any work, make sure you're wearing safety glasses and gloves. Battery electrolyte and corrosion deposits contain sulfuric acid that can burn your skin and eyes. Also, work in a well-ventilated area. As mentioned before, batteries emit hydrogen gas, which can explode if it accumulates. Batteries are typically located in the engine compartment. Most batteries today are of the maintenance-free variety with sealed cells of electrolyte. Some batteries have an electrolyte indicator, or eye, mounted on the top of the case. If the eye is red or black, like this one, it indicates that the battery is discharged. If it's green, the battery is fully charged. A clear eye indicates low electrolyte levels. Don't try to recharge a battery with a clear eye. The electrolyte levels are too low to safely charge the battery and it could explode. Inspect the battery terminals, cable connectors, and cables for signs of corrosion, those greenish-white crystals. Corrosion is a normal part of battery life, but if it isn't cleaned away periodically, it can damage clamps, cables, and other parts and inhibit battery operation. So if corrosion is present, clean it away. Continue your battery inspection by examining the condition of cables and connectors and the battery case. If the case is cracked, replace the battery immediately. A cracked battery can soon leak corrosive acid into your engine compartment. Never try to charge a leaking or damaged battery. Cables with damaged connectors, frayed insulation, or excessive corrosion should be replaced. One thing to remember, when you disconnect the battery, electronic devices may lose their settings. Radio stations, clock, power seat positions, keyless entry combinations, all of these will be lost unless you use a memory saver. These devices plug into the cigarette lighter and use a 9-volt battery to deliver enough charge to maintain settings while the battery is disconnected. To clean the battery, begin by disconnecting the negative battery terminal. Move the negative cable end away from the battery before disconnecting the positive side. Use a cable puller to remove the cable connectors if battery terminals are severely corroded. Be careful not to damage the terminals or connectors if you're going to reuse them. Loosen the hold-down clamp and remove the battery. Spray the battery terminals and cable ends with battery cleaner. Let it work for a few moments, and then flush with water and wipe dry. Use the post end of a battery cleaning brush to remove any remaining corrosion from the battery terminals. Repeat this cleaning procedure on the cable connectors, battery tray, and hold-down parts with a battery cleaner. Let the cleaner work for a few minutes. Rinse with water and wipe dry. Use the cable connector end of the battery cleaning tool to clean the cable connectors. Replace the battery cables if the ends are severely corroded or if the metal connectors have deteriorated so that they no longer clamp firmly to the battery terminals. Replace the battery. Secure it with the hold-down clamps, then reconnect the battery cables, positive side first. Finally, spray the battery terminals with sealer to inhibit future corrosion. So, if a battery isn't working properly, what do you do? Do the state of charge test using your DBOM as shown earlier. Frequently, batteries in vehicles that have been sitting around the shop for a number of days can lose their charge. If you get a low reading, try charging the battery. Disconnect the negative battery cable. You can remove both to be extra safe. Make sure the battery charger is off before you connect the battery. Attach the charger clamps to the battery, first positive, then negative. Next, set the charger. We want a fast charge, so we'll set it to high and 12 volt. We'll also set it to maintenance free. Set the time. Now on this charger, that also starts the charge cycle. On a fast charge cycle, the battery will charge in about 20 minutes to 2 hours, depending on how low its charge was. When the charger is finished charging, make sure it's off. Then remove the charging cables in reverse order from the way you connected them. First negative, then positive. Reconnect the negative battery cable. You'll want to do another state of charge test to ensure that the battery is fully charged. But before you can do that, you must remove the surface charge. A surface charge is the uneven mixture of sulfuric acid and water along the surface of the plates created during charging or discharging. It'll make a weak battery appear good or a good battery appear bad. So turn on the headlights for 30 seconds to 1 minute to remove the surface charge. Then, using your DVOM set to DC volts, measure the battery state of charge again. This battery shows a full charge of 12.6 volts. You may wish to perform a couple more tests to ensure that the battery will hold a charge. While leaving your DVOM connected to the positive and negative battery terminals, start the car. Cranking the starter will reduce the voltage reading about 2 volts. But as soon as the car starts, the voltage should increase about 0.5 to 1.5 volts above the resting voltage, in this case to 13.77. To make sure the alternator is supplying an appropriate level of power to the battery under load conditions, turn on the air conditioning and the high beam headlights, two of the highest loads. If the voltage stays half a volt to 1.5 volts higher over the resting battery reading when these loads are applied, the alternator is working properly to recharge the battery. One other thing to inspect while you're under the hood is the serpentine drive belt that runs the alternator. Look for fraying on the edges or cracks on the grooved side of the belt. If you find either, replace the belt. Also, check the belt tensioner. Take a wrench and move the tensioner to see if it's applying tension to the belt. Replacing the serpentine drive belt is a simple operation. However, before doing so, check to see if there's a diagram showing belt placement and direction. It's usually found on the inside of the engine compartment. If there is no diagram, draw one. You don't want to remove the belt and then realize you can't remember the proper path for installing the new one. To remove the old belt, pull the tensioner away from it, and it should be easy to slip it off the pulleys. To install the new belt, thread it through the pulleys following the diagram. Make sure it's oriented in the same direction, in this case, grooved side down into the grooves on the pulleys and smooth side out. Compress the tensioner to finish threading the belt on the last pulley. Once the new belt is installed, release the tensioner. The new serpentine drive belt is ready to go. Tension adjusts automatically. Well, there you have it, Vehicle Electrical Systems 101. Obviously, there's a lot more that we didn't cover, but now you know enough to perform some basic tests as part of collision repair. You learned about current, voltage, and resistance and how the three are related in an electrical circuit. You learned how to use a digital voltage ohm meter, or DVOM, for testing electrical circuits and loads. You also learned how to perform a battery state of charge test and how to clean, charge, and replace a battery. Finally, you saw how to inspect and replace a drive belt. Remember, in auto body work, you have to know a little about every system in a vehicle, including electrical. But there's a lot to know, and nobody has all the answers. So if you run into trouble, don't be afraid to ask.